Hey guys, welcome back to another Algebra 2 video. In this one, we're going to talk about determinants and inverses of matrices. And we're not really going to get into what those things are or what they're used for or why we have them, not in this video. I'm just going to show you how to figure out what they are, how to find them, how to calculate them. And in the next video, a separate one after this, we're going to talk about the motivation behind them and what you can use them for. Okay, but I didn't want to give you too much in this first video. I just want to get used to the mechanics and show you how easy it is to actually calculate them, and then get into the theory and you know the uses later. Okay, so what's a determinant? Well, let's start with a matrix. Let's say I have a matrix A, and it has some numbers here, like that. And I want to find the determinant of A. Well, there's a bunch of ways I can write that. I could write the determinant of A. Another way you could write it is the determinant of A, and you use these bars here. So what I'm going to do is I'm going to go up to my matrix, and I'm going to notice, or I'm going to pay attention to this first diagonal. I'm going to multiply these two numbers together. So that's 3 times 5. And then I'm going to subtract the multiplication of these two numbers. So that's 4 times 2. Now, if you do that in one motion, it looks like this. This is the way I remember it. It looks kind of like a fish. So you start from the top left, swoop down, and then go back down to the left. And when you do that, 3 times 5 is 15, minus 4 times 2 is 8, and that's going to give me 7. So that is the determinant of that matrix. And that's all there is to it. You multiply, you subtract the two answers, and you get the number. All right, let's do another one. I'm not necessarily going to name this one. That'll work. Now, if I wanted to say that I want to find the determinant of this and it's not named, I could put determinant out front, but more often you're going to see this. You're going to see the entire matrix written again, but you're going to see it written with these vertical bars. They look like absolute value bars, but that just means take the determinant of this matrix. All right. So I'm going to do my little motion here. That means 3 times 6 minus, it's always minus, 5 times 4. That's going to be 18 minus 20, which gives me negative 2. And there's no problem having a negative number as a determinant. Very simple. That's all there is to it. All right, let's do another one. Why don't you guys try this one? 5, 7, 3, and 2. All right. Actually, let's use this notation this way. Let's use a different letter. Let's call this one B and say I want to find the determinant of B. So you might see it that way. All right, try this one, and then we'll do it together. All right, so I'm going to go down from the left, swoop around. That gives me 5 times 7, which is 35, minus 2 times 3, which is 6. That gives me 29. And that's the determinant. Again, super easy. No need to make this complicated. Don't overthink this. All right, let's try one that's slightly trickier. Let's make a new matrix, C. And let's give it some numbers, 5 and 2 and 3, and let's do negative 3 and 4. All right, let's find the determinant of C. I'm trying to show you all the different notations. Notice I'm kind of writing it differently every time. All of these things mean the same. All right, I encourage you to try this one on your own, and then, as always, we'll do it together. All right, let's see how you did. So I'm going to do my swooping motion, and I have 5 times 4 minus, now this is a negative 3 times 2. This is where people get this stuff mixed up, and they make mistakes here almost almost all the time when they start out. So 5 times 4 gives me 20. And now this is a negative 3 times 2, which gives me negative 6, right? But what's going to happen here is you're subtracting a negative number. So that's actually 20 plus 6. So the answer is 26. So be very, very careful with your negatives, especially since the determinant always has a subtraction sign in it. So you're going to have to, be aware if you already have a negative, you're going to have to switch those signs. Okay, so that's how you find a determinant. Now you can find determinants of larger matrices. You can find determinants of 3x3s, 4x4s, but we're not going to get into all of that stuff. That's beyond the scope of what we're going to do, at least in my class. And if you want to find out how to do that, I'm sure there are plenty of other places, plenty of YouTube videos you can search to find a 3x3 matrix determinant. But again, that's beyond the scope of what we're trying to do here. And because we're going to use this to find the inverse of a matrix. So let me show you how you do that. First of all, I need a matrix. Let's use 1. Let's call it A. And let's go with 2 and 4 and 6 and, I don't know, 5. Sounds good. All right. Now, I'm not going to get into why we're finding the inverse or even what an inverse is, because I'm going to dedicate an entire video to that after this one. All right. But I find that when I go through that first, it kind of bogs things down and it makes this seem way more difficult than it is. So I'm just going to show you how to find them first. You're going to get used to finding them, and then I will show you why. The first thing we're going to do is find the determinant of A. And so we're going to find the determinant of A. That's going to be 2 times 4, which is 8, minus 5 times 6, which is 30. So the determinant is going to be negative 22. All right, so that's the first step. Here's the next step. I'm going to take this matrix, this original matrix. Let me get rid of that. And I'm going to swap some numbers around, do some things to it. The first thing I'm going to do is swap these two. And I remember it this way. When I'm finding a determinant, I start from the top left. That's kind of the first swooping motion, right? If you go through this, it goes this way. So that's the thing that I'm going to be swapping, those two numbers. So over here, I'm going to write 4 and then 2. They're just switching places. And the other ones, the 6 and the 5, I'm not going to swap their places. I'm going to leave them where they are, but I'm going to change the signs. So if they're already positive, I'm going to make them negative. If they're negative, I'm going to make them positive. So don't just think I'm making them negative. I'm changing the sign. So if it was already negative, you'd make it positive. Then what I'm going to do is take this determinant here. I'm going to put it under 1. So I have negative 1 over 22, and then this matrix. Now there's going to be one more step. Now what I'm going to do is multiply everything in this matrix by that. I'm going to distribute, if you will, this negative 1 over 22 into this matrix. And it looks really bad, but it's really not bad at all, because this is always going to be a 1 on top. So really all you're doing is putting that 22 on the bottom. Let me show you what I mean. Let me actually give me some space here. So it's going to be negative 4 over 22. All I did was to divide it, I just stuck it down there. Or to multiply it, however you want to think about it. And then this is a negative times a negative. That's giving me a positive 6 over 22. And then at the bottom, I have a positive 5 over 22, because I'm multiplying a negative times a negative. And then I have a 2 over 22. Now, at this point, it is the inverse. But I want you to, reduce these fractions. So we're going to look at these and see if we can simplify them. So 4 over 22 can be reduced down to, well, if I divide both of them by 2, I get 2 over 11. 6 over 22 can be 3 over 11. So I'm just dividing them both top and bottom by 2. The bottom one can't be reduced because there's no common factor there. and then the bottom right one is going to be 1 over 11. And that, on the right, is my inverse. Now the symbol for that, for inverse, is A with a little -1. Don't think about that -1 up there as doing anything. It's not doing anything. It's not calculating anything. There's nothing you have to do with it. It is just a symbol that says, hey, I'm an inverse. That's it. Okay? All right, let's recap. You find the determinant and then hold on to it. Then you swap two of the numbers. You switch the sign of the two of the numbers. You put the determinant here. You multiply through and then reduce if you can. And then you're done. All right, let's do another one. I feel like we need to get some practice in with these. Let's do, I've got white already. Matrix B, 3, 4, -2, 1. All right, now if you're feeling confident, I would suggest going ahead and trying this one on your own. Just do what I just did, exactly the same way, and then come back and I'll walk you through it again. All right, let's go ahead and find our determinant. So the determinant of B is, if I do it this way, I have 3 times 1 is 3, minus 4 times -2 is -8. So my determinant is actually going to be 3 plus 8, which is 11. I'm going to save that for later. I'm going to go over here and write my new matrix. So this B is inverse is going to be 1 over 11 times, and now I'm swapping 1 and 3. And then the other two, remember I'm changing the sign. Now this top one is positive, so I'm going to make it negative. But the bottom one, this bottom left, -2, well, it's already negative. So I'm going to switch it to a +2. It's just like I said before, I'm not making things negative. I am switching the sign. All right, now I've got to multiply through with 1 over 11. So let's do that. So the first one is now 1 over 11. That's easy. -4 over 11, 2 over 11, and 3 over 11. And in this case, there's nothing to simplify. So then we're done. And that's our inverse. I feel like this looks really crazy the first time you do it because there's a lot of steps to it. But after you get some practice and you get used to it, it's not too bad. All right, let's do another one or two of them and then we'll be done. Here's a matrix C. And let's go with that. All right, definitely try this one on your own. If you haven't tried one on your own before you've watched me do it, definitely try this one and then come back and see how you did. All right, step 1, determinant. Determinant of C, that's going to be 50 minus 12, right? Because I did this whole thing right here. So 50 minus 12 is going to be, what is that, 38? Oh, that's a terrible 8. All right, so my determinant is 38. We're going to hold on to that and use it in a minute. Now I'm going to go over here. Let's use a different color. The inverse of C is equal to 1 over 38 times this new matrix, which we are going to get from the original. We're going to swap 10 and 5, and then we're going to make this negative and make this negative, because we're swapping the signs. Now we're going to multiply through. So now I have 10 over 38, -6 over 38, 2 over 38, that's negative, right? And then 5 over 38. Okay, one more step. Let's use a different color to denote that we are going to have our final answer. So C inverse is, well, I can divide the top and bottom by 2, so that would give me 5 over, what is that, 19. Same thing here, divide this by 2, I get -3 over 19. And this one's going to be, divide this by 2, -1 over 19. This is going to be 5 over 38. I can't reduce that one at all. And if I did all my calculations correctly, that is C inverse. All right, I think we're going to cut it here. That should be enough to show you how to find determinants and use those to find inverses of matrices. And hopefully you come back for the second video where we actually I'm going to show you how to use these and what they're for, why in the world we use them. All right, so thanks for sticking with me, and I hope you followed along. I hope you learned something, and I'll see you guys in the next video.